Um, we're just going to skip this little part right here. I just don't like talking about that stuff. It usually confuses people. We're going to go straight down to warm up 2. Yesterday, what we did was we took right angle triangles and we found side lengths. Today, what we're going to do is we're going to take right angle triangles and we're going to find missing angles. All right, there's a couple different strategies we're going to use. The main one will be SOHCAHTOA. Just a reminder, everything we do has to be on a right angle triangle. Right, so you have to have an angle like this to do what we do. Right? Otherwise, Pythagorean theorem doesn't work, SOHCAHTOA doesn't work, and we're kind of out of hope. Right? So if you don't have a right angle triangle, you have to create a right angle triangle. Most of our examples have one, so it's easy, but I just want to make sure that's in the back of your head that this is always for 90-degree triangle. Awesome. We're going to do this example together. Again, I don't really do it the way they do it, so it's going to be slightly different. We're going to start off by looking at our triangle. Okay. It says find the missing angle, and they've labeled an angle A for you. All right, so they want you to find this angle. So that's the angle they've labeled. To find a missing angle, you need to be given either 2 side lengths or the other angle. In this case, they gave us 2 side lengths. When they give us 2 side lengths, our strategy to find the missing angle is SOHCAHTOA. So the first step of SOHCAHTOA is label your triangle. So again, we're going to look at this thing. We're going to label our triangle. Across from the 90 degree is your hypotenuse. Across from the angle that you're looking for is the opposite. And the third side is the adjacent. Fantastic. Now that you've labeled your triangle for SOHCAHTOA, you write out SOHCAHTOA and you use it as a checklist. All right, so I'm going to write out SOHCAHTOA. Remember that SOHCAHTOA represents my primary trigonometric ratios, sine, cos, and tan. It's a short way of telling us 3 different formulas. When you're checking off things in SOHCAHTOA, you want to check off the first 3 letters of each, the S, the C, the T, they're 3. Then you want to put a check mark underneath the side lengths you know. In this case, you know 2 side lengths. You know adjacent and you know hypotenuse. So you're going to put a check under A and a check under H. When you do that, one of your formulas should have 3 checks. The 1 to 3 checks is the one that you're going to use. Right? This is telling me which formula to use. This is telling me use the cosine equals adjacent over hypotenuse. Remember that? I'm just going to write it right here. Cos equals A over A. That's what it just told me to do. Okay, we're going to try to use that formula, except we're going to fill in numbers. So when we set up that formula, we're going to go cos. We don't know what the angle is, so you're going to put bracket, whatever they called the angle, and then close the bracket, like that. So that means cosine of angle A equals adjacent side divided by hypotenuse side. In this case, adjacent is 16. Hypotenuse is 34. So I have cos of A equals 16 over 34. Okay, at that stage. Yesterday we had to get x by itself, right? The side length by ourselves. Same idea here. We need to somehow get the angle by itself. And we always say you do like the opposite operation, right? So if you have addition, you do subtraction. If you have multiplication, you do division, right? You always do the opposite. The opposite of cosine. We call it second cos because that's the buttons you're going to press on your calculator, but it's inverse of cosine. Okay, it looks like this. On your calculator, It's probably the same button as cosine. Okay? On these calculators, it for sure is the same button. All you have to do is hit second and then cos. That's why we call it second cos. Right? When you hit second cos, this should pop up with a bracket. Try it. When you do that, what you've done is you've taken your angle and you've taken your ratio and you've switched them spots. So now it's second cos 16 divided by 34 in the brackets. And that will equal A. So my calculator, I go second cos, 16 divided by 34, and hit enter. I get, I'm in the wrong mode. If you got 1.08, you're in the wrong mode. Remember, your calculator has to be in degree mode. I don't even know why I tried using that calculator. I knew it was broken. Your calculator has to be in degree mode to work, otherwise this won't work. So you go second cos 16 divided by 34, and you find out that your missing angle is an error. Oh my goodness. Okay, this time I got 61.9. Is that what you guys got? Beautiful. When we round angles, we round it to the nearest whole angle. Right? So side lengths, we always do one decimal. For angles, we just go nearest whole angle. So 61.9 would round to be 62 degrees. That's how you find missing angles. So it's literally like the same process. It's just the isolation's different. Right? The only time you'll use second cos is if you're looking for an angle. If you're looking for a side length, you would use regular sine, regular cos. Awesome. We'll do a few more examples together. I think 3 examples together, and then we'll talk about a couple of definitions. So, in each case, calculate the measure of the indicated angle. I'll do one more with you, then you can try one more on your own, and then we'll talk about the third one. A. I'm looking for a missing angle. This is the angle they labeled for me, so that's the angle I'm looking for. To look for an angle, I need to label all the sides. This is opposite. This is hypotenuse. This is adjacent. Once I've labeled my sides, I use SOHCAHTOA, so I write out SOHCAHTOA. Underneath SOHCAHTOA, I'm going to check off S, C, and T because those are my freebies. And then I'm also going to check off the side lengths I know. In this case, I know the opposite is 4 and I know the hypotenuse is 6. So I'm going to check off O and H. Sine of opposite over hypotenuse has 3 check marks. That's the ratio I want to use. Now that I know that's the ratio I want to use, I'm going to fill it out. And then I'm going to put any numbers in where they should be. So for this, I'm going to go sine of A, because I don't know the angle, equals opposite, which is 4, divided by hypotenuse, which is 6. Sine A equals 4 over 6. Your goal is to figure out the angle. That means get the angle by itself. To solve for an angle, you hit second sine, which brings up this inverse sine for little -1. And then the fraction switches spots and goes into the brackets. Like that. You can actually calculate second sine 4 over 6. When you calculate it, second sine, bracket 4 divided by 6, I get 41.8. Round that to the nearest angle. That means that angle A equals 42. Not bad, right? Okay, try the second one on your own. Give it a shot. I will do it with you. And then if you want to try the third one, you're more than welcome to. Okay, so for B, I look at this triangle. It's asking me to find a missing angle. I notice it's a right angle triangle, so I'm like, okay, I'm going to use SOHCAHTOA because I have two sides. With the two sides, I have to label out my sides for SOHCAHTOA to operate. I label them opposite, hypotenuse, adjacent, like you've seen here. On the top, I write out SOHCAHTOA. I put check marks underneath the S, the C to T, because they're free spaces. And then I put a check under the two side lines I know. I know H is 19, I know A is 10. So I put check marks under those two to get COB. That means use the cosine ratio, right? Cosine is adjacent over hypotenuse. Awesome. Now that I've chosen my formula, I can start right here, and I can fill out my formula. I change the angle to BB because that's what they call the missing angle, right here. I call it adjacent 10 because I know it's 10 long. I call the hypotenuse 19 because I know it's 19 long. My goal then is to get the angle by itself, so I do second cos. This guy comes up, and I put in the brackets that ratio. I then calculate it second cos 10 divided by 19. I get 58.24, so I round that down to be 58 degrees as the answer. Fantastic. All right, third question. We look at that one. The one that makes this unique is that you have all three sides. So, for instance, if you go to do SOHCAHTOA, which you definitely can, it's opposite, adjacent, hypotenuse. And I go to do my checklist, so I'm going to write out SOHCAHTOA. So slow, so it doesn't do that little drag the letter across. And I go to check off my things. I do my three free spaces, the S, the C, the T. But now when I go to check off the sides I know all three. So I'm going to check off O, H, A, H, O, A. I've got all of them. What that means is I can use any of the ratios. And they'll all give me the exact same answer. So it's really your choice. If you have one you prefer, use it. I usually use 10 because, I don't know, TOA sounds cool. So that's why I use 10. Right? But use any of the three you want and you'll get the same answer. So when you run into this situation where you have more than one box with checks, just pick one and work with it. Pick anyone you want. This here doesn't matter. Okay, so go ahead, see if you can finish that off. Use any one you want. I'm going to use 10. Beautiful. So if you did that using sine, cos, or tan, you should have ended up getting 46 degrees. I used 10, so mine was 21 over 20. That's the opposite over adjacent. And I would have gone second tan, put that inside the brackets to get my angle. It was 46.397. 46.3 would round down to 46. Awesome. That's finding angles. Not that bad. Let's talk about something you know that you probably forgot that you know. Okay, and that's how to find the third angle in a triangle. So I'm going to go back to all three of these triangles, and I'm going to just fill in what I know. I know this one's now 42. I know this one's now 58. And I know this one is now 46. The question is, how could I find the other angle without using SOHCAHTOA? Because there's a much quicker way with the other angle. Rock, paper, scissors. How do you do it? Go ahead.
You add up the corners and subtract it.
You got it. Right? All angles in a triangle equal 180. I heard someone just talk about this the other day, and they were saying 120, and they kept getting it wrong. I was like, oh, that's got to be frustrating. So they all add up to be 180. That means if I go 180 and I subtract the other two angles, so subtract 90 because that's a 90 degree, and subtract 42 because we now know that's 42, it will tell you your missing angle. In this case, it would be 48. So if you have the other angle, it's really easy to find your third angle. Just remember that trick, because it will pop up every once in a while. It should be like a really quick question, and sometimes people take a long time because they do SOHCAHTOA. But in reality, just do your trick. So 180 minus the other two. So for this one, if you went 180 minus 90 minus 58, you end up with 32. This one, 180 minus 90 minus 46, you get 44. Looks like 94. That's a 44. Hey, there we go. All right, the last thing we're going to learn in this lesson is definitions for two terms called angle of elevation and angle of depression. They're quite simple, and then I think we'll do one question with them. So angle of elevation, angle of depression is just a way to describe which way an angle is going. So when you're talking about angle of elevation, it's upwards, right? Elevate, lift. Angle of depression is downwards, right? You're feeling down, depression. Angle of depression would be downwards. When you think of these two definitions, so if you have a question and they say, well, the angle of elevation was 50, the angle of depression was 72, you always have to measure your angle to a horizontal line. And that's the tricky part with these two definitions. All right? We like to think of it as like line of sight, like an eyesight. So if I'm talking about angle of elevation, imagine my line of sight, there's like a horizontal line coming out of my eyes, which would be pretty cool. Angle of elevation is up from that horizontal line, depression is down from that horizontal line. But it's always connected to a horizontal. They've drawn a picture here for you to show you the angle of elevation from the boat to the helicopter is right there. In a word problem, sometimes people make a mistake and they'll think it's here. But it's not, because the blue one I just drew doesn't connect to a horizontal line, a sideways line. It connects to a vertical line. Right? So make sure whenever you're placing these definitions in a problem, it's always to a horizontal. Alternatively, you can do angle of depression from the helicopter to the boat. So if you did angle of depression from the helicopter to a boat, you would do a horizontal line from the helicopter and then go downwards. And see how I've connected to a horizontal line. What it isn't, is it isn't this right here. That's not right. The reason that's not right is because that's a vertical line. You want to connect to a horizontal line when you're using these two terms. Sometimes I've read the word elevation as inclination, so they'll say like the elevation of the angle of inclination. It's the same thing. I don't think you'll see that, but just in case you do, if you're doing homework for somebody else, which I don't know why you'd be doing that, but hey, who knows? Right, it should be elevation depression. All right, usually talking about the definition doesn't really do much for us. We just kind of got to do some questions. Let's try one. Okay, this question. A tree, 5.1 meters tall, casts a shadow 7.5 meters long. Calculate the angle of elevation of the sun to the nearest degree, tenth of a degree. Okay, when I do word problems, I like to read it once and then somehow try to draw out a couple things. So I've drawn the tree and the shadow. Remember the shadows are on the ground, right? Sometimes people mess that up and they think it's in the air. It's not. It's on the ground. Then I reread the question and I start labeling things. So, a tree, 5.1 meters tall. I come over here, my tree is 5.1. Cast a shadow that's 7.5 meters long. Shadow, 7.5. Right now, I don't have a triangle. Right? So you need to turn that into a triangle. The way we're going to turn that into a triangle is it talks about our sun. Our sun would be up here. Yeah, beautiful. And that sun created this shadow by beaming light from the top of the tree to the end of the shadow. Right? And it technically goes all the way up to the sun. But that's how the shadow gets created. Now we have a triangle, right? And remember, every question should be a triangle somehow. At the end of the day, you're usually just connecting the two big strong lines, the legs. Perfect. We keep reading the question. It says, calculate the angle of elevation of the sun to the nearest degree, 10th of a degree. Angle of elevation means you should be connected to a horizontal line and go upwards. In this question, the angle of elevation is right here. Horizontal line, upwards to the sun. See how that works? Now that you know what you're looking for, I like to call that thing x. Now I can solve that problem. At the end of the day, every word problem you do will turn into a right angle triangle, where you have to do SOHCAHTOA or Pythagorean theorem or something along those lines. But at the end of the day, it's just a triangle, right? And it's like every practice problem we do. So word problems aren't that much more challenging. You just turn it into a 90-degree triangle, try to solve what's missing. In this case, we're missing an angle. When we're missing an angle, I check to see what I know. I know two side lengths. When I know two side lengths, I'm going to do SOHCAHTOA. So I'm going to label them opposite, adjacent, hypotenuse. Once I've labeled my beautiful triangle, I write out SOHCAHTOA, and I use it as a checklist. SOHCAHTOA. I put a free check under S, C, T, and I put checks under things I know, which are O and A. Tells me which one I need to use. Just gonna take a second here. Can you guys see the yellow? Is that really hard to see, or is it actually pretty good? Good? Okay. Now that I know that I'm using TOA, I go tan, bracket, whatever the angle is. In our case, we don't know the angle, so we put x. Equals the opposite side, which is 5.1, divided by the adjacent side, which is 7.5. I've chosen my ratio, I've set up my formula, I need to get whatever my letter is by itself, in this case it's x. To get x by itself, I do second tan. And any time I'm calculating an angle, I do second. Second tan, second cos, second sine, one of those three. When I do that, it switches them spots, right? So my ratio is now inside, the x is on its own, which everybody enjoys that, right? You go second tan, 5.1 divided by 7.5. Second tan, bracket, 5.1 divided by 7.5. And you get 34 degrees. It says nearest 10, so I should do 34.2. But I'm just going to say 34 because I already wrote it. That means the angle of elevation to the sun, so upwards towards the sun, is 34 degrees. Easy peasy, right? Angle of elevation up, angle of depression down. And we've got one more here. We got a boat. Okay. A boat is 130 meters from the base of a cliff. The cliff is 80 meters high. All right, I have a cliff. And a boat that's probably out on some water. I can't draw a boat very well, so this is my boat. Pretty nice drawing. That makes sense, right? This is my cliff, this is my boat out on the water. Now I read the question again and I try to label things. Alright, it says a boat is 130 meters from the base of the cliff. That means from the bottom of the cliff. So down here, that means I have 130. The cliff is 80 meters high. This right here, the cliff, is 80 meters high. Currently, we do not have a right angle triangle. We need to add one more side to it. I'm going to add this side right here. And now I have my 90-degree triangle. I don't know what I'm looking for yet, but I've drawn a diagram that represents the question. We keep reading the question. Draw a diagram to represent the scenario. Beautiful. Mark the angle of depression of the boat from the top of the cliff. This is the hard one. Angle of depression. Okay, so a lot of people, if we did this question, would say the angle of depression from the top of the cliff to the boat is right here. However, that's not correct. Why is that not correct? Because it's not connected to a horizontal line. Perfect. Right? This connects to a vertical line. Not good enough. We need to connect to a horizontal line. In this case, we don't have a horizontal line at the top of the cliff for angle depression. So we invent an invisible one. And we look for that angle right there. That would be the angle of depression from the cliff downwards to the boat. It's just not a part of our triangle. That's why it screws people up sometimes. Just remember, horizontal line, and you'll be good. All right, there's two ways to do this question. The first way is to continue on with this dotted line that I created. And make another triangle. Like that. See how I've made a triangle up here in the air? And I actually know different sides of that triangle. I know that this is 130. This is the same as right below. And I know this is 80. Because it's the same as across from it, right? I've just created a rectangle. And you could do all your work on the triangle in the air. And you would get the right answer still. Second way to do this question. Second way to do this question is to realize that the angle of elevation and the angle of depression, if they're in the same triangle, are actually the same thing. If they're in the same rectangle. So for instance, when they talk about this is the angle of depression, this would be the same angle. These two things are equivalent. Right? This is the angle of elevation from the boat to the top of the cliff. This is the angle of depression from the cliff to the boat. They'll be the same thing. So you could do this question with the regular triangle and just solve for angle of elevation. And that would count as well. Tricky, right? I prefer to do the one in the air. That's just how I can visualize it. Although I do understand some people have a hard time seeing that, and they would rather do this one down here. Either way, you have to label your triangle. When you label your triangle, you're going to have opposite, adjacent, hypotenuse in the middle, opposite, adjacent, hypotenuse in the middle. And you'll notice those triangles are the exact same. Both have an opposite of 80, both have an adjacent of 130, both have the same hypotenuse. It's the same triangle, it's just flipped. Right? It's on the other side. Either way, you're going to use SOHCAHTOA. You're going to do 3 checks, and you're going to figure out that TOA is the one you need to use. No matter which way you solve it, you end up with TOA. That means that the tangent of our angle, which I've called x, equals the opposite, which is 80, over the adjacent, which is 130. When you're looking for angles, you do second tan. Second tan, like this, and then 80 over 130. When you do that, anybody have the answer? 31? Thank you very much. You get x equals 31 degrees. Around is that?
No, that's not rounded. It's 31.6.
31.6. What's it want? Rounded to the nearest. Oh, it doesn't. I'm ahead of it. to the nearest whole degree. So yeah, it'd be 32, 31.6, right? So 32, yeah. 32 degrees. I just did part B and part A. Calculate an angle, not that bad, right? And word problems don't get that bad either. We have a question here. I'm just going to talk about it really quick. We'll talk about it. We'll talk about it. We probably won't solve it. So it says, consider the isosceles triangle KLM from K to L is 20. K to L is 20. L to M is 20. L to M is 20. And K to M is 30. We're not going to spend the time to solve it, but we are going to spend the time just to discuss what's going on in it. So, with that triangle, if I said, find the angle KLM, or find some angle anywhere, I'm like, find this angle. Why couldn't we find it? There's no 90 degree in that thing, right? And that's why we can't find it. It almost looks like a 90, right? This looks pretty close to 90, but it's not. Unless they tell you it's 90, or it's a word problem where like you have a wall in the floor or a cliff in the boat, right? Like that kind of stuff, that'll be automatically 90. But if they just give you a triangle and they don't label it 90, you should question that. And ask me. Maybe it's just a mistake on the test or something. Maybe they just didn't put the 90 in there, so feel free to ask. But if it's not 90, you can't do SOHCAHTOA. Right? So you can't do anything. What we need to do is turn that into a 90. The way we're going to turn it into a 90 is by taking advantage of the fact that these are the same side length. Alright, if those are the same side lengths, then I could turn this into two 90-degree triangles. And the way I could turn it into two 90-degree triangles is by cutting this perfectly in half. Actually, there's when I do that, I create a 90-degree right here and a 90-degree right here. I then also created two sides that are 15 long, not 30. And now I have a triangle here I could work with, and I have a triangle here I could work with, and I could solve anything I need to solve. If I need to solve missing angles, I could do that. If I need to find missing side lengths, I could do that. Okay. In this case, it does ask you to find K to L to M. That's this angle here. The only way I could do that would be by solving this side and solving this side, and then adding the two angles together. All right, we're not going to go through that work. I know that you have time to practice for the next little bit, but it's just finding two missing angles, just like we have been. Right? You use SOHCAHTOA, opposite hypotenuse. You're using sine ratio. Beautiful. That is finding missing angles. Any questions?